We are going to look at numbers 5 through 11 odd in section 2.2 of MA 104, Elementary Function. For these problems, we're asked to find the distance between the points and the midpoint of the line segment joining the points. When applicable, we're to leave our answers in radical form. We know that the distance formula tells us that the distance between 2 points is equal to the square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. So if I apply this formula to the points that I'm given, my x-coordinates are the first coordinates, so that would be 1 and 4. So I would take 1 minus 4 and square that quantity, and add it to what I get when I subtract the y-coordinates, which would be 0 and 4. So 0 minus 4, quantity squared. 1 minus 4 is negative 3, so I have negative 3 squared, plus 0 minus 4 is negative 4 squared. If I square each of these quantities, negative 3 squared is 9, plus 4 squared is 16. So the distance is equal to the square root of 25. Since 25 is a perfect square, I can say that the distance is equal to 5. So the distance between those points is 5 units. The midpoint formula tells me to take the x-coordinates and add those together and divide it by 2, and then take the y-coordinates and add those together and divide it by 2. So again, if I follow my formula with the coordinates, the x-coordinates again are 1 and 4, so I will take 1 plus 4 and divide that by 2. Then I'll take the y-coordinates, 0 plus 4, and divide that by 2. 1 plus 4 is 5 over 2, and 0 plus 4 is 4 over 2. 5 over 2 we can leave as 5 over 2. If you'd like to change it to 2.5, that's fine. But 5 over 2 is sufficient, and 4 divided by 2 is 2. So the midpoint of the segment joining those 2 points is 5/2, comma 2. To find the distance between these points, again, I apply the formula. I will subtract my x-coordinates, so that would give me 0 minus 5, quantity squared, plus subtracting the y-coordinates gives me negative 2 minus 10, quantity squared. Working inside the parentheses, 0 minus 5 is a negative 5. I'll be squaring that. And adding it to negative 2 minus 10 is negative 12 squared. Negative 5 squared is positive 25. Please recall that when you square a negative number, you will get a positive number back. If you want to square a negative number in your calculator, please make sure that you include the parentheses around the negative number whenever you enter it. Otherwise, your calculator may read it a little bit differently than you intend. It may read it as the opposite of 5 squared. But in any event, we know that when we square negative 12, we'll also get a positive number, specifically positive 144. This tells me that the distance is equal to the square root of 25 plus 144, which is the square root of 169. Again, 169 is a perfect square, so the distance is 13 units. For the midpoint, I again want to add those x-coordinates, so 0 plus 5 over 2. Add the y-coordinates, negative 2 plus 10 over 2. Simplify, I get 5/2 and 8/2. The 5/2 again can remain as 5/2, and 8 divided by 2 is 4. For these coordinates, plugging them into the distance formula gives us the square root of negative 6 minus 3 quantity squared, plus negative 4 minus 4 quantity squared. So I find that the distance is negative 9 squared plus negative 8 squared. simplifying, negative 9 squared is positive 81, plus negative 8 squared is positive 64. So the distance is the square root of 145. 145 does not have any factors that are perfect squares, so the distance is equal to the square root of 145, which is in radical form. I can't simplify that any further, so I'll leave it as the square root of 145. The midpoint I will again find by adding my x-coordinates together, so negative 6 plus 3 over 2, and my y-coordinates, negative 4 plus 4 over 2. If I simplify, negative 6 plus 3 is negative 3 over 2, and negative 4 plus 4 is 0 over 2. So my midpoint is negative 3 halves, 0. Finally, to find the distance between these 2 points, I have to be careful when applying the distance formula. Subtracting the x-coordinates, I have negative 6 minus a negative 2. The x-coordinate of the second point is negative 2. So when I subtract a negative 2, that's actually the same as adding positive 2. So I'll have negative 6 plus 2 quantity squared, plus negative 3 again, minus a negative 1 is the same as plus 1 quantity squared. So this tells me that the distance is the square root of negative 6 plus 2 is negative 4 squared, plus negative 3 plus 1 is negative 2 squared. Simplifying further, negative 4 squared is 16, plus negative 2 squared is 4. So I find that the distance is the square root of 20. The square root of 20 can be broken down into the square root of 4 times the square root of 5. So this tells me that the distance is equal to the square root of 4, which is 2, times the square root of 5, which can't be simplified any further. So the distance is 2 square roots of 5. The midpoint, I will take the x-coordinates, so negative 6 plus a negative 2, divide that by 2, and the y-coordinates, negative 3 plus a negative 1, divided by 2. If I simplify, this gives me negative 8 over 2 for the x-coordinate of my midpoint, and negative 4 over 2 for the y-coordinate, which, simplifying one more time, gives me negative 4, negative 2.